So now our second part of activity one is to identify the load-bearing surfaces, and we sort of addressed that just a moment ago. But we're going to identify which parts rub or run on each other to keep them in place. And then we're going to identify them by name, and then we're going to find those what we call nominal dimensions. Okay, when I click on it, what dimension comes up before tolerances are applied. So let's take a look. Again, now we can see over here a little bit that this outside of the gear is going to run on the inside of the housing, but it's hard to see here. So let's look at a sample drawing, and now you can see. Okay, there's a little pocket. One pocket for the driven gear, one pocket for the pinion. And this little flat area right here. Let me see if I can make that bigger. You can see here there's a little flat area and then what's called a chamfer. Okay, and the little flat area goes all the way around, and that little flat area is where the outside diameter of the gear goes. And the inside diameter of the housing holds the gear in place. It can't go sideways, it can't go up and down because it's constrained by that whole circle, except for this little area where they meet. It's still enough to keep everything really all together. Okay, so we have outside diameter of gears, inside diameter of the housing. Okay, so on the housing, at least I can get those dimensions. Here's one, 1.335. That's the nominal. That's the nominal diameter of the inside of the housing. And here, 4.935 is the nominal. So we were supposed to find out where parts will rub. The outside of the gear will rub on the inside of the housing for each gear. To identify those dimensions by name, ID, inside diameter of housing, OD of gear. And for the housing, at least, we've seen that we've got this 1.335, which is this diameter right here, and 4.935. Those are my nominal dimensions. And you can go look them up for your gear.